Good afternoon, all. As we discussed yesterday, we are going to start with next chapter of the book. The slides are from the book's website, so it reads chapter number 5. But we are still in module number 2 of our syllabus. Okay, it doesn't change our module, though the chapter changes. Okay, so today we are going to talk about a typical category of AI problems, which are generally referred to as constraint satisfaction problems. Okay, so constraint satisfaction problems, we have looked at one of such problem, which is n queens problem, wherein we wanted to configure the chessboard such that it has n number of queens when the chessboard board size is n cross n. Sitting on the chessboard, no two queens attacking each other. So that was the definition of the n queens problem. In general, an n cross n board, n queens sitting on the board without attacking anyone else. So that's the definition of n queens problem, and we know that that problem is a bit different from other state space search problems. The other state space search problems were the problems where we wanted to reach the goal node through understanding what actions followed us to the goal node. Whereas the n-queens problem, we are interested in configuring the board such that the constraint of no two queens attacking each other should be satisfied. Also, the other constraint in this particular problem is that there must be n number of queens if the size of the board is n cross n. Okay, I hope this makes sense that these problems are different from the state space search problems, as I said already. Okay, I hope my voice is audible. I did not ask it at the beginning, and okay, I've already shared the screen, so screen must be visible and voice must be audible, right?
Yes, it is fine.
Thank you. So we're going to see three things in this chapter. So if you see your syllabus, they just talk about introducing your the syllabus talks about that we should introduce you to what is a constraint satisfaction problem, what are the different kinds of CSP problems that are seen in the literature, and we should also tell you about what are the naturally occurring real world CSPs, where exactly I can use the understanding that we learn here of the about the CSP problems. But they never say in the syllabus to teach you algorithms to solve CSP. Okay, so as an outline of the chapter, we see here three sections. First section talk about constraint satisfaction problems, what they are. Okay, second section talks about what does backtracking search means and how it can be applied to solve CSP problems in a much crisp manner than the usual search algorithms of informed and uninformed categories that we already talked about. Okay, the third section in the book talks about the local search, so application of local search algorithm, the last bit of topic from our search algorithm topic, informed search basically algorithm topic, which was local search. We studied three algorithms over there. Number one was hill climbing, number two was beam search, and number three was the simulated annealing modification to hill climbing algorithm. There is one more algorithm called a genetic algorithm. As I blindly told you that I'm not going to consider it to be part of our discussion because it's not there in your syllabus. Similarly, here these two last topics, we will look at them because they're interesting. Because after looking that only, you will understand that, okay, doing state space search is not the only way to solve the problems, but there are different ways as well. And to realize that, to get that understanding, we will waste certain time of our schedule to discuss what is backtracking search, and we'll also discuss about certain heuristics based solution to CSP problems. But mind well, that particular topic might not that be important with respect to your syllabus, whereas the first section of this module, or rather not module, chapter, that is notion of what is constraint satisfaction problem, what exactly it means, how it differs from the state space representation of the problem. So how in the characteristic it is different from state space problem, and also how it is different from the way of representing the problem, okay, as a abstract representation. Okay, so दोनों देखेंगे हम लोग. We'll also learn how it is different in its characteristic compared to state space search, and how the constraint satisfaction problem is in its representation as a AI problem different from the state space search problem, which involves you determining 5 things about the problem. When you define the state space problem, you determine 5 things about the problem. Number one is the state definition, wherein you define the initial state. Then you define the the actions, valid actions. Using these 2 things, you define the transition model. Then you define the goal test, and maybe you also define the cost considerations. What exactly are the cost consideration for every action? So these 5 things make up a state space problem. I will also try and understand what does CSP problem is made up of. Okay, so that's what we are going to talk about in today's discussion. So let us begin the content without wasting much time. So this slide tells you about what exactly is constraint satisfaction problem and how that is different from standard search problem. Now, whenever you read this word standard search problem, here they mean the state space search problem that we learned in chapter number 2 of the book. Okay, so in the book chapter number 2, they teach you about state space representation of an AI problem. So standard search problem is that. Okay, so in standard search problem, the state is like a black box. So any data structure that supports successor function, heuristic function, and goal test. So state is considered for a standard search problem as a black box. That black box only has certain functionalities that can initiate the change in the values. One is the successor function. Why we require successor function? Because successor function determines our transition model, which is required for finding out the action sequence. Secondly, we also require a definition of heuristic function into the state, okay, integrated into the state, or maybe if not heuristic function, there must be some way to define the cost, as I told you already, the path cost. Okay, next thing that we require is we require to do a goal test. So these 3 things are integral what you can say methods that operate on state, but the state itself is like a black box. Every time I look at the state, I only look at certain attributes of that particular black box and manipulate those to work on changing the state from current state to some other state. That is the meaning of that word black box. Now, CSP, on the other hand, here the state is defined by variables xi. So now we actually talk about internals of the state. So the definition of state of the problem is definition of these internal variables. Okay, so that's an important distinction between a standard search problem and AI and CSP problem. Okay, constraint satisfaction problem is shorthanded as CSP, so I'll be using this word CSP often. Okay, the values of these variables are from a certain domain. So 2 new concepts get added to the definition of state. Now state is no more a black box, but I actually will be manipulating the state and defining the state in terms of certain variables. That is what usually you do when you are doing a representation of a class and an object. So you define certain attributes inside that class. So our state is like a class which has an attribute set, and every attribute will have certain domain, and the values of that attribute will always be chosen from the domain itself. And this particular thing is first kind of constraint that we need to follow. That's the first kind of constraint that we need to follow, that every variable that defines the state will have a domain, and I must choose one of the domain values so that to define a particular state. So that is what I had written here last year, s of xi, xj, xk. So this is how, using these 3 variables, maybe I'm defining a state s. xi has a domain di, so xj may have certain different domain or it may have the same domain. Xk may have its own domain or it may have a different domain as well. So what naturally comes is a particular state would be a combination of some instance value from the domain di for variable xi. For variable xj, I could use different letters as well, no issues, but then it is better we use the x only, and then there is a k x. So these are instance values. So if I instantiate these variables from their respective domains, so there will be di, dj, dk, three different domains from which I'll choose a value. And once I instantiate it, I will get one single state representation, which I may call it as a S instance or SIN. I'm referring it to as a S instance. So this is one of the state of my problem. This is how the problem state is defined in terms of CSP. Now you'll say that even state space search अगर state ही define करना तो ऐसे ही कुछ होगा, but then please understand the distinction. वहाँ भी attributes हो सकते हैं, but we do not give it importance. We do not give it importance to check whether every time we do any activity while solving the problem, we do not keep on checking the constraints of the domains of the variables in the state. स्टेट के वेरिएबल्स के डोमेन का कंस्ट्रेंट हम लोग चेक करते नहीं है फॉर मेनी ऑफ द standard state space search problem, but we consider that to be one single black box. That's the distinction between it. You'll realize it in more apparent way when we discuss about our first problem in CSP category of problems, and that problem is called as graph coloring problem, which is written over here. So when we actually try and talk about, we try start to talk about these problems. Three problems we are supposed to learn, as your syllabus also says. One is the graph coloring, other one is script arithmetic, and the third one is n queen's problem. Okay, ये खींचना अलग चीज को था, खींच गया अलग कुछ चीज. Okay, let it be. Now, the other important point about CSP is that whenever we are defining a goal test, what we do is we have certain things in the problem that are referred to as constraints. Okay, so constraints means what? Restrictions. Restriction posed by the definition of the problem. Restrictions apparently we see in the variables that define the state. To choose value for every variable from the respective domain is first and foremost kind of constraint that we just apparently see in front of our eyes. But there could be certain constraints that are defined by the definition of the problem that we are solving. And such constraints take part when we are carrying out the goal test. So all the constraints that are specified by the problem definition must be satisfied by the state to be called it as a goal state. Okay, so that exactly what they read over there. Goal test is a set of constraints specifying allowable combinations of values for subsets of variable. Okay, variables के subset को कौन से values allowable होंगे? Which value from the domain of xi should the variable xi take such that that particular value subset can be part of a goal test. So I will be doing goal test in this particular manner, checking out